All right, so our next speaker is Cosmo Wolfe. Cosmo is interested in using technology to unlock data, especially in the education, healthcare, and transportation industries. He enjoys working on building and managing web security and identity systems and teams. He works at Clever, building software for schools and specifically working to ensure that Clever's code base empowers the engineering team. His talk today is going to cover a series of approaches he used to migrate a monolithic backend that served several hundred pages slowly to be React TypeScript single-page apps without sacrificing user or developer experience. This process allowed engineers to actively develop on the code base despite the ongoing migration and increased feature development velocity. But most importantly, it did this all while maintaining the user experience. So everybody give it up for Cosmo.
Got this all set up, but we have to do a little cable movement. Ah, it worked. Almost. There we go. Cool. This talk is called The Promised Land, and usually start with saying it's not about JavaScript promises, so if you're coming to learn about asynchronous programming, you may be disappointed, but you already learned that. Instead, it's about upgrading legacy code bases. And so a lot of us are here and we're kind of learning about you go to conferences and you learn about the exciting world. 3 new JavaScript libraries were being created during the last talk, as he said, or the first talk. But when we go home to our jobs, none of us kind of have the luck probably to work on kind of brand new modern code bases all the time. If you do, treasure that, because the nature of the job is that we're a lot of time maintaining legacy code or trying to upgrade legacy code, and we're trying to ship more features to our users or ship more improvements, but we can't just focus on only feature development, because in the code the code will eventually degrade, or you can't just focus only on upgrading code because then no feature development. And so that sort of trade-off is something that I've thought a lot about at my company recently, and I want to cover some of the work that went into that. Hopefully you find something of value in those discussions. So like you said, my name is Cosmo. My website's up here. And that is my Twitter and my GitHub and my email and I'm in your Slack now, so you can Slack me if you have any questions. I love talking about this stuff or really anything, so please reach out. I'm in town from San Francisco, where I work for Clever. Like I said, Clever is an education technology company. We try to make it easier for schools to use software. And so schools will buy a lot of software and try to get it set up with their legacy identity systems and legacy data systems, and all the whatever systems the schools use can be difficult for everyone involved. And so Clever kind of connects to the school there on the left, to all whatever their systems that they have. We bring the data and the users kind of through Clever and then expose it over kind of modern APIs to applications like Khan Academy, so it's easier kind of for everyone involved. We got started about 6 years ago now in 2012, and we built this kind of this flow of data. And the first thing all of our customers said, okay, like the data goes in, the data goes out, but how does it work? What's going on in the middle there? And so we built the next part of the product, which is something that almost every company has in some way or another, which is some sort of like online account dashboard that your users can log into, you manage their settings, as long as any company has somewhere that their users can log in, and if you do, it probably looks something like this. This is a pretty old screenshot, so hopefully not exactly like this. But this is the oldest screenshot I can find. This is in 2013, I think, so it's actually a fair amount of development happened between the initial creation and this. But this is a pretty standard web app. We built it at the time using Node.js on the back end and not a ton of front end. Like the front end was mostly just HTML and CSS. The back end was where all the logic lived, and we were rendering templates and then just serving those to the users. And over the last 6 years, that has kind of evolved and changed because this is our main user-facing entry point to our product. And so nowadays, this is a screenshot I took a couple months ago. It looks, similar, but there's a lot more features and a lot more kind of pages and whatnot. And I think when this project got started, it was about a year and a half ago, and like I said in the intro, we were serving around a couple hundred distinct pages, like a settings page, a Teams page, a home page, kind of a couple hundred distinct pages, and each page was powered by 3 or 4 different routes that, on average. So the settings page maybe had a get and a post and a delete or something. And so this web app, for us, it was one of our larger ones by surface area, not by traffic. For other people, it may be huge. For other people, it may be teeny. But this was our sort of main web app and the one that had the largest surface area at the time. And growing out from that kind of, the initial page, like very simplistic web app, back and rendering everything to this more modern one where we had pages with lots of micro interactions and little like sliders and more rich UIs and whatnot, was a process that was put a lot of load on the original code base. It did not grow gracefully, I would say. It got to the point where page loads we were looking at were averaging around a second or more for some of the pages, which is for us, that was an order of magnitude higher than we wanted. To load the homepage for some of our customers, this is the homepage. We would make the same call to internal data services, like load the same data from the same internal data service like 7 or 8 times, which is just insane. It's like one time, should be enough for that. And it got that way from a combination of reasons. One is, we were using technologies in 2012 that we kind of got less support as time went on. Like we used CoffeeScript in the back end. I don't know, for those of you who don't know, CoffeeScript is like a transpiled to JavaScript language that has more like Ruby-ish syntax and kind of is the worst of both worlds in hindsight, I think. But so we used CoffeeScript in the back end, and CoffeeScript support kind of went down as ES6 and ES Next and the more modern JavaScript started to gain popularity. We also, we had ways you laid out the code made it maybe you didn't even realize data was being loaded in multiple places. And as the engineering team grew and that kind of tribal knowledge went down, it became harder and harder to enforce it. Like, okay, we shouldn't be making these duplicate calls. And so we had this repo where it was, difficult to develop on, difficult to make changes to features, or to make changes or add features easily, and was just generally slow. And on top of all that, I don't know how many of you know like Hofstede's law, which is basically software development always takes longer than you expect, even when you expect it to take longer than you expect. So we have, this is just, I think, a universal truth. And this is actually a variation of this. This is true. The whole story is true, but this specifically is, we wrote this down in like our Jira, is engineers and PMs started to throw around the clever dashboard law, which was saying basically if you take Hofstede's law and you double it or just continue to add features, dashboard development often will take multiples longer than expected, even when you kind of expect it to take longer. And so we'd have engineers and sprint plannings doing like geometric regressions, just try to figure out how much time it was going to take to add a button to a page. And the answer to that was sometimes days. And again, like depending on how your development practices or whatever, days might be fast to add a button to a page or glacial to add a button to a page. For us, it was certainly on the slow end. Most of our code bases, we push to productions multiple times a day. And so if it was like, oh, we just want to make a button here that does something, and the engineers were like, oh, that'll take a day or two at least if we account for the dashboard law, that was feeling pretty untenable. And so all of those things combined, we said, okay, we have this repo that is hard to develop on, it's slow to our users, and it's slow to develop on to make it faster. Like, what are we going to do? And we set about kind of fixing this, doing kind of a one-time fix-up, hopefully. And so we set some goals. There's a lot of kind of internal goals, like don't use this outdated data source or whatnot, but the goals that I think kind of relevant to the general process. The first one is we wanted to make like a single page web app. So like I mentioned earlier, we had a lot of the kind of micro interactions and more rich UIs. And so we were doing a lot of kind of JavaScript on the front end. So then your server would do a bunch of logic. It would send it to the front end. The front end would then spin up a front end web app and consume that information and do a bunch of logic on that. And it got to the point where we were kind of re-implementing a lot of stuff. And we said, okay, if we're going to make these kind of rich UIs, we need to make code run on the front end to like empower those UIs. We should just make a single page web app so users click around, no hard page reloads, everything feels super fast. To power that, we wanted to use React and Redux. We're not going to talk, the code examples that I'm going to show are going to be in React just because they're pulled straight out of the GitHub repo, but there's nothing specific about this talk, React. I don't think you'll actually see any Redux, but these were technologies that we had used in other places in our code base, and we kind of, we'd seen our engineers be empowered by them, so we wanted to if we were going to kind of like upgrade this repo, we wanted to use the patterns that we had seen successfully at other places. Same with TypeScript. There was a lot of benefits from TypeScript, some of which were giving us more modern JavaScript features like async and await. That's your promises, the only promises reference in this whole talk from the beginning. We also like the idea of having kind of a strongly typed language as we start to build more and more of our code in this front-end JavaScript. So we use TypeScript. Again, you'll see that in the code examples a very little bit, but it's nothing specific to TypeScript here. We wanted to make kind of stateless backend APIs. So we have the single page web app where all the logic and all the UI is happening, and that would be powered by calling these like stateless backend APIs. So there's no more of this like the different routes are loading the same data a bunch of times. You have like a single backend API for a single piece of data. You authenticate with it. It's super easy to test. It's easy to write. You can start to separate your teams between like front end and back end if you want. That kind of ties in nicely with the single page web app and the Redux. And then the final point, and this is like a little bit more of a meta point, but it's also, I think, the most important in my mind, was we wanted to make it easy for engineers to do the right thing and hard for them to do the wrong thing. And what that means is, we didn't get to this point where this code base was kind of difficult to develop on accidentally. It's not like we woke up one day and realized it. There were lots of kind of efforts throughout the years to make improvements here or there. One of the biggest ones is trying to move off of CoffeeScript, because we saw kind of CoffeeScript causing development problem very early on. And so we, take a couple engineers, spend a couple weeks, maybe we'd port 30 or 40 CoffeeScript files over to JavaScript. And in the time those like two kind of like fix-up engineers were working on that, you'd have the other 10, 15 engineers writing 10 or 15 new features. Each one would just go into the repo, follow the patterns that existed, and write a bunch of JavaScript or CoffeeScript files. And you'd end up, at the end of the day, you'd have gotten rid of like 30 or 40 CoffeeScript files because of the kind of cleanup, but you'd have 50 or 60 added in the same time, and it's kind of pushing a boulder up a hill. So we thought if engineers, if it's not easy for them to do the right thing, if it's not the kind of, they just go in and they just follow the normal practices and they don't have to like remember some presentation or some email or something from the past, then the code base will trend worse. And so we have to make it easier for them to do the right thing if we want the code base to trend to a better direction. And so that's sort of I think the most important point, but it also is difficult, right? Because we have this like giant code base, a large percentage of our engineering team is working on it at once. How do we kind of switch it out for a new code base without kind of having to pause feature development or whatever? It became a difficult choice, and there was a lot of internal discussions between these two. And it's like, oh, if we took all the engineers that were developing new features and we put them just on doing this rewrite, we could do it in 1 month, and that's 1 month of feature development lost, and like that, then the magnification of that will be so much better once we're in the new world. But at the end of the day, management, product management or just engineering management, this is untenable, right? This is our number one product. This is the product users are logging into every day. There are bugs in it. There are features that we have, timelines that we've committed to externally. We can't just do this trade-off between, we can't just say no feature development while we do a rewrite. We have to kind of do both at once. And so that adds this kind of fourth point, that fourth point, or last point I should say, which is basically we need to maintain feature development velocity no matter what we do. And that kind of trade-off is what led to these projects. So with that, I'm going to talk about 3 approaches we use. They are chronological. So we started with one, we made improvements, went to the second and the third. So kind of implicit in that is that the third one, this D2 approach, is the one that worked the best for us. The reason I'm talking about all 3 of them is because I don't think that's a universal truth. I've given kind of variations on this talk before, and almost always there is at least one person in the audience who is excited about each one of these. So I want to kind of give all 3 and kind of talk about the trade-offs, because 1, the context is helpful, and 2, just because it worked for us does not mean it will or won't work for you. So without further ado, let's talk about DOM Snatcher. DOM Snatcher is, the name comes mainly because we like funny names for internal projects at Clever. And so, a little bit of internal branding can always be fun. But it also, as you'll see, relates to kind of how this approach worked. And the general idea behind DOM Snatcher is if we want engineers to write new pages in React, we have to make it easy for them to write pages in React. And so if the UI Chrome, the kind of standard UI that's on every page is not in React, then to write a new React page, you have to write a new backend route that renders a backend page that sucks in the UI Chrome. That backend page has to set up a new React app, and then you can write your page in the React app. You have to do like 4 or 5 extra steps just to do the right thing. So in interest of making it easy for engineers to do the right thing, we say, if we have to make it so the UI Chrome, the kind of standard interface that engineers work with when they're writing a new page, should be in React. And so how do we make this part of the page in React while still supporting the legacy pages? So now this is a little bit of specific to front-end apps, so I'll give you a tiny bit of context on that, but if you already know, just, I guess, follow along. A front-end web app, the HTML you get back from the server looks something like this, where there's no content or anything from the server. The server just gives you back an empty div and a script. The script tag then is what sets up the React app, and all the logic that lives for your UI, it lives in there and gets kind of hydrated into this div by the front-end code. That is to contrast with a page like this, which is, this is one of the server-side rendered pages. You can tell because it looks kind of funky. And what this would look like coming back from the server is something a little bit more like this. And so, you have this content div that's all rendered by the server. So like the, all this stuff is the server spitting out. And so, if you have this like React app that does the sidebar and the header and the UI Chrome, and you also have this server-side content that maybe also gets a sidebar and a header and UI Chrome, like how do you suck up the server-side content into the React app? That is where the DOM Snatcher approach comes into play, because we need to snatch this content into the React app. And so I'll do some more code examples of this. If you're not familiar with React, this is how you set up front-end routes. So all of these routes will be navigated between with no page reloads. The server only gets hit on the initial one, and then everything else is just the front-end code handles. And so you can say, like, the home page gets handled by this home page component, and the account settings page gets handled by the account settings page component. And then the approach that we took with DOM Snatcher was to say, okay, and then all other paths get handled by this DOM Snatcher component, and DOM Snatcher will grab the backend content out of the server-side rendered DOM and drop it into the UI Chrome of the general app. And so this is probably going to be the most specific React slide, but if you are familiar with Angular or Backbone or anything else, you can hopefully kind of see it in that model as well. So all DOM Snatcher does is, when it starts up, doesn't do anything. When the component's about to be added to the page, we just use like the traditional APIs to look for that content div of the server-side rendered content, grab the inner HTML out of it, remove it from the DOM basically, and then sets this internal tracker of inner HTML for this component. And then this component just returns, I don't know if you can see that because of my head, but just returns a div with that inner HTML content. This dangerously set inner HTML is how you do inner HTML in React. And so all this component does, you can drop this component anywhere in the UI tree, in your React tree, and it will look for any server-side rendered content on the page and insert it into the React app where it is being used. And so this allows us to we write a React app. Everything's done front end, and then any server-side rendered content we can snatch into the React tree. And so this allows a page like this. It gets rendered by the server. The server may also return the header and the sidebar and whatnot, but we will just not display that. The header and the sidebar are then rendered by the React app, and then DOM Snatcher sucks this up into the kind of the content area here. And we can navigate between pages very easily because this homepage, if it's all modern React or whatever, is just being rendered by the front-end web app, and then you can navigate back to this page, getting DOM snatched out from being rendered on the server. And it kind of accomplished the goal of now it's easier for engineers to write front-end web apps, front-end web app pages, because all they have to do is write that single page. They don't have to worry about all the scaffolding that they traditionally would have to worry about. The downside of that is it mixed old and new patterns. And so, if you're changing one page, you have to change some back-end rendered content. If you're changing another page, you have to change a front-end page. If you're trying to create a new page, it's much easier for you to use React now, but it's not necessarily guarantee that that's the right way to do it, because you'll look at all the other pages, you look at a page similar to what you're trying to do, and you may still kind of follow old patterns. We also, after rolling this out, saw engineers who wanted to create a new page using React. They knew they wanted to use React, but they still followed the kind of pattern of creating a new backend route that initialized a new React app. And then, funnily enough, that got DOM snatched into the new React app, because it's just hard to, hard to kind of convey best practices if most of your code base does not follow them. And so the mixing of old and new patterns was the main downside we saw with his initial kind of DOM Snatcher approach, and led us to create our second approach, which we call DOM Snatcher After Dark, which was a more kind of goofy internal branding, but with the goal of being much more aggressive DOM Snatcher, basically. We wanted to make it much more kind of clear where the lines between the new code base and the old code base were. And while we were at it, we figured we could avoid kind of the downside of DOM Snatcher approach, where when you navigated the legacy pages, you still had to do the whole round trip to the server. And so to do that, we said, let's say let's make a brand new code base. Everything Light touches is the new code base, except we'll cordon off the old code base, the old CoffeeScript files and the old patterns off on their own. And we will do that by writing a new code base from the ground up. So now engineers don't have to worry about mixed patterns. We have this brand new code base, and the code base is, like I say, front-end web app where we hit stateless APIs, and one of those APIs can provide context for what legacy pages are. So if you navigate to a legacy page, we make a call to an API, and we figure out what the content is, what the scripts are, that kind of thing. I'm not a huge fan of architecture diagrams, but I think it's probably worth putting one up. So the user is navigating just to the front-end web app. There's no user never sees any hard page reloads. The new dashboard is then talking to the old dashboard via API. The user is never hitting the old dashboard directly. And so to do that, we created some sort of proxy, and this is a node, but it's just a very simple proxy. You could probably do it with something like just like Nginx config or something. But it's an API route that when you hit it, takes in a URL in the query. So it takes in a URL and then uses that URL and hits the old dashboard with an authentication token that's basically saying, okay, this is the user that's trying to access the content here, and it takes back whatever content it gets from the old dashboard and sends it through. So it's a pretty straightforward proxy. We still have the same routing setup. Only now we have this DOM Snatcher After Dark component. And the DOM Snatcher After Dark component is a lot more complex. It's because now this component, instead of just looking for the content in the page and grabbing it out of the existing HTML DOM, we have to kind of load it over the network. So when the component starts up, we kind of keep track of loading, true, no inner HTML, no scripts yet, because we're just in loading. This will if we're loading, we kind of return a loading indicator down here in the render. And then in the will mount, we take the current URL that we're at, which we know is a URL that corresponds to a legacy page in the legacy dashboard. We then make an AJAX call, using a promise, so going back to the beginning, making an AJAX call to that legacy proxy. And we get back the scripts that the page needs and the inner HTML that the page renders, and then we kind of throw that into our component state. And then down here, now we're not loading anymore, so we again say the strangely set inner HTML. And so that looks pretty similar, only loading over the network, except we have this big to-do, because once we've loaded the content into the DOM, we need to do a bunch of stuff to set up the scripts that we now load and stuff, because it's no longer all handled by the server. And so this to-do kind of became the biggest downside of this DOM Snatcher After Dark approach. I don't know if you've seen this owl owl drawing instruction manual, but the to-do, the component here is basically this version of the owl, and we need to get here before we can show it to our users. And so there's kind of the rest of the work there. This is stuff like we need to update static asset URLs, because now the static assets are in this like cordoned off API version of the dashboard. So we need to somehow get the static assets through the same proxy. Oh boy, what was that? Clicker bug. So getting the static assets is something that luckily for us was pretty easy with Webpack. But you can add this public path to your Webpack config, and it will kind of prefix all the URLs and stuff that Webpack outputs with that. So by saying like public path legacy proxy with the URL, it allowed us to kind of get all the assets loaded through that proxy. But it was still, we had to do that. We also need to load the scripts. If you recall, the API was returning the scripts the page needed, but we need to kind of attach them into the DOM. This is a very simplistic version of how that worked. You also have to like kind of remove the scripts from the DOM when you navigate away, and we also wanted to keep track of like loading and whatnot while the scripts were loading. But the simplest version, we're able to say like for each of the scripts that we got from the API, attach them to the DOM. We need to convert all the like link tags to React router links, so when the users click on them, they don't get the hard reloads, because that was kind of one of the goals of this, was no hard reloads. And so again, this is a pretty simplistic version of that, but we were able to say, find all the links in our DOM for each of them. And when you click on them, instead of doing the default behavior, do a React router push so the user doesn't get the hard page reload. You just navigate to the new URL. Again, this is like the 90% solution of that. There's additional nuance and stuff when you have like click handlers and whatnot, but just to give you a general deal. And form submissions are probably the most complicated part, because if you throw the form submission into the page's HTML and the user clicks on it, one, you need to send the data through the legacy proxy to go to the legacy code base, and two, we wanted to again avoid these hard page reloads. And so the form submission code got fairly complex fairly quickly. It started out looking something like this, where when you say when the form submission happens, take the data, serialize it, get the URL and the method out of the form, set loading true again, so we have a loading spinner again, and then make another request to the legacy proxy with that data, and then whatever we get back, kind of use that content and start the whole process over. And again, this is like the 90% solution. And you might be saying like, Cosmo, you showed us like this is the important part, right? Like these kind of gotchas. Why are we seeing the 90% solution instead of the 100% solution? And this is why. I don't know if you've seen this saying before, but that last 10% work ended up taking 90% of the time. It got to be fairly complex very quickly, and we would still be finding edge cases that like, oh, when our users do this and then that, and then they click on this thing, we lose track of the event listeners, and so the page, gets borked. And so we ended up spending a lot of time kind of tracking down this like last 10% of the work, and it got very difficult very quickly. And also, it made it very difficult to develop on the legacy code base. The legacy code base, remember, is a web app, but we turned it into sort of an API that returned HTML content and scripts. And so if you wanted to make a change on that, like a change that without any sort of substantial impact, like something not just like a copy change, it would be very difficult to do, because you'd have to either run both code bases locally, or you'd have to just like change it and like inspect the HTML that the API returned, or it basically became fairly untenable to make any sort of meaningful changes to the legacy code base. And remember, most of the pages are still in the legacy code base, because the whole point of this is trying to set up a solution that allowed us to not have to port everything over right away. And so I'm actually very excited about the kind of DOM Snatcher After Dark approach. I think when pulled off successfully, it is the best case scenario for the users. They get kind of like a free upgrade to being a modern front-end web app with very little developer impact besides this like legacy code base kind of slowdown. The trade-off there is unless you don't follow very strict practices, like you have kind of like abstracted away creating forms and all of the kind of knobs that you can do while creating new pages, you end up having to track down this like long tail of people doing random stuff in the legacy code. So if you were using something that kind of has very predictable output, I think building sort of a DOM Snatcher After Dark setup would work very well. I was talking to some folks at another company where that was exactly what they did. They had some sort of Ruby framework that was doing most of the actual HTML rendering, so it was very predictable, and they were able to build sort of a DOM Snatcher After Dark where everything got kind of upgraded into a modern web app for free. But for us, it was too varied, and so we ended up kind of continuing towards the promised land, not stopping here. But if you can pull it off, I think it's the best solution. This clicker, there we go. The final attempt, and the one that we kind of use today and have seen the most success with, has the least exciting name. We just call it D2, which is short for Dashboard 2. But the general idea behind D2 is we're going to, again, write a new dashboard from the ground up, same as Untitled Chapter Dark. So users will only be developing a new code base. There'll be no mixed patterns. And instead of doing this kind of complex upgrading of the legacy code into a modern web app, we will just do a direct proxy through. And so there won't be any sort of like mutation of the content as it moves through the proxy. It'll just be, if you click to a legacy page, you'll just see that legacy page exactly as rendered by the legacy code base. As part of this, we also renamed our legacy code base, which was originally just called Dashboard, into Trashboard. One, because D2 was not exciting enough as a name, but this is not just a joke. This is actually, I think, something that was fairly beneficial in hindsight, because if you're a new engineer at a company and you get a task with, build this feature into the dashboard, and you're not exactly sure, you've heard that there might be two dashboards or something, they might be talking to each other, but you're not exactly sure how that works, and you go into our GitHub and you search for dashboard, you'll see two repos. You'll see D2, the future of dashboard development, and you'll see Trashboard, and when you see that, it becomes fairly clear which one you probably want to be working on. And so that kind of little soft guardrails, I originally thought was just a funny, again, kind of funny internal branding, but it's actually had a lot of benefit just by kind of helping nudge engineers in the right direction as they choose how they're going to develop new features. So this is kind of a fun aside of this approach. And so the architecture diagram looks fairly similar. The new user is talking to the new dashboard. The new dashboard is proxying requests directly through to the Trashboard. So no kind of upgrades or anything, just direct pass through. And so the key to this was something that we just call the giant file. This is a very truncated version because it needs to fit on some sort of monitor. But originally this started out as about 300 lines of Trashboard routes. And it's just a direct white list of these are the URLs that have to be mapped through to the legacy code base. So if you go to the home page, it used to go to the legacy code base, but now that's handled by D2. But any of these other pages, if you go to them, you'll just get directly proxied through to the legacy code base. And if you're not logged in and one of your sessions haven't synced over or something, the legacy code base will just return a login page, and just like it used to. There's no kind of there's no nuance around that. It's just a direct proxy. You could do this at your networking level. This is something you definitely do at the Nginx level as opposed to having to do any application code. We did it still using application code because it worked better with our networking setup. But again, very kind of vanilla proxy. So here's an exact. This is the code pulled directly out. It's proxy request function becomes much simpler. It just passes them through, no authentication changes or anything because the cookies just get passed through too as headers. It's a pure proxy through. The Trashboard routes, we take each of the gets and the posts and the patches and deletes, and we set up this proxying of requests through there. We also do some sort of general setup for images and style sheets, the kind of the static assets that we need to proxy through. And then at the end, we register all these API routes. I don't know if you can see that, but the only trade-off here that you have to be cognizant of, or that we had to think about a little bit, is you can't have URLs that exist in both, right? Because if there's a list here, it's never going to be served by the new code base. And so we just prefixed everything under /API or API v2 or something for the new code base, and then any routes that didn't have that prefix were kind of safe to proxy through. But if there was a collision of routes, that would be something we would have had to address ahead of time. So with this proxy set up, there we go. With the proxy set up, we no longer have the sort of DOM snatcher. We now just have this very simple catch-all component. So any route that isn't handled by the new app, we send this catch-all. If one of the Trashboard routes matches that URL, if the URL we're at is the Trashboard route, we can just do a hard page reload, which will trigger the network request to the server, which then gets proxied to the Trashboard. Else we just return a not found page. It's if you're at a URL that's not handled by the Trashboard, not handled by the front end, then you're at a 404. This component is 6 lines, which is infinitely fewer than the gigantic DOM Snatcher After Dark component grew to be, and much simpler even than the simple DOM Snatcher, while also giving us the benefits of having these 2 fully isolated code bases. So the other benefit of this was that there was no changes to the existing code base required. The trash board, if you will, we didn't have to change it to return HTML as an API or change scripts or anything. It just runs behind our internal kind of VPC, thinking that it's running as it always has been. People hit it, it gets URLs, it sends back login pages, get URLs, sends back content. People navigate around. It's still slow. There's no changes to the code base required at all, which means if you need to make changes to it, you can just run it locally and make changes as you always would have. It's impossible for us to have slowed development speed down because the old code base development patterns haven't changed at all. Even if this project had no impact on development speed, that would be better than kind of slowing it down. And so by not changing the old code base at all, we kind of ensured that we'd only have upside on development speed. It also allowed the whole team to contribute to upgrading pages by having the new code base fully isolated. People who were very excited about writing React and kind of leveraging these new patterns were able to jump right in very quickly. And people who were kind of I just want to get my feature out the door, I don't want to learn how to write React or something. Over time, we want everyone to converge on using technologies that we as a company use. But for now, they were able to just use the kind of development patterns they were used to. With a little bit of friction of having to add or change that trashboard routes file, but in practice we actually saw that very few people wanted to do that. And like I mentioned earlier, the feature development speed couldn't possibly slow down, but we did see feature development speed increase probably by about not on order of magnitude, but at least by 200%. Just looking at kind of commits made over time and features pushed, because as people started to leverage the new technologies, they realized that the kind of the benefits that we'd seen from React and Redux and TypeScript on other repos also applied here. And so those were 3 major wins of this kind of D2 approach, and that was kind of the successful execution of this promised land. This promised land approach is that we saw feature development speed increase while also moving fully to a world where new coding practices were the state-of-the-art coding practices were the current state of the repo. And so the promised land, just kind of to recap, we had a clear right path. This is what made this the promised land for us, is that there was a clear right path. When you're working in the new code base, you know exactly what you're doing, and we discouraged people from working in the old code base. It allowed us to move as slowly or as quickly as we wanted on this port. In the year and a half since we started this project, I think we've ported over all except for 2 large pages, 2 complex pages in the old code base. So now we have all those hundreds of routes. Those have all been ported over just sort of by general developer momentum on wanting to use new features on the new code base. Those legacy pages, there are reasons that we haven't been able to port them over yet. But this is also something you could do for years. The folks I was talking to earlier who did the kind of more DOM Snatcher After Dark approach, they say that's always going to be the case. They're probably never going to go back and port over the legacy pages because they think it's good enough, and they want to just continue to focus on shipping to their users. They probably also weren't as in as bad of a place as far as page load times and whatnot as we were. The carrot and the stick of having the kind of the good features is the carrot, so you can use the new dashboard and get faster feature development, and the stick of being a little bit softer of a stick as maybe changing into an API or something, but by having the backend be named trashboard, and also kind of this additional layer of having to have the URL whitelist that you'd have to edit, has kind of gently pushes people to do the right approach without kind of being too aggressive about it. And if this is something that you're interested in, I'll remind you that it's very easy. It can be as simple as a URL whitelist in Nginx or something. We have since used this approach for other kind of repos internally, including some non-user facing ones, just to kind of help move these kind of code bases that have been around since the early days to a world where we can now develop on them quickly again. So that's the promised land in my mind. That's how I see it. I'm Cosmo. Please reach out to me on Slack or on any of the links on my webpage. I'm also on Twitter. Just search for my name. I think we're doing some Q&A, but yeah. So there you go.
So same drill. Just raise your hand. I'll come find you for questions.
Did you measure your speed increases when you switched to a single-page web app, and what was the impact of that?
The development speed or user-facing speed?
User-facing speed.
Yeah, so we did that in a couple of different ways. The one is we measured, we kind of like built into our deployment system, we measure just server-side route responses. So the single-page web app, users are navigating around without ever hitting the server directly, but they're still making API requests to load data and whatnot. And so we set pretty aggressive bars for just the server-side endpoint response times to make sure that those weren't getting down to like the multiple second times that we were seeing in the old page. So we measured that and just like kind of held ourselves to very strict limits on that, much the same way as we hold kind of our publicly facing APIs to those response limits. And then on the front end, assuming there's no server load, no data required to be loaded from the server is instant, or like effectively instant, as fast as the JavaScript runtime can execute, the update. And so by using that, the only other thing that we did there is we measured sort of kind of time to all the store, the data store being hydrated from the back end. And that's sort of different depending on where the users come from and stuff, because as you navigate around, if you've already loaded the data from the back end, we don't load it again and whatnot. But just making sure that our general page loads there were much faster, which we saw those being, again, because the server-side response times were so much lower, very directly tied to that. So yes, it was much faster. I don't have like the exact numbers off the top of my head. I think like the multiple seconds for the original homepage, and in the new world, the homepage was under 150 milliseconds, I think. But I don't have my data pulled up exactly. And that's like because both the backend endpoints were usually like probably 50 to 75 milliseconds, and then we had to hit them a couple different ones to load the data for the homepage. So there's another one over there. There's someone over here, I think.
So is there automated testing in the legacy app and the new app? And if there wasn't in the old app, what was it like trying to get the developers to add that onto their development?
Yeah, I feel like anytime you talk about testing, it's like either there isn't or there is, but not as enough as we'd like, And so for the legacy code base, there were tests since basically day zero. Whether or not they were effective at catching bugs is a different question. So our developers are used to writing tests, and some of them are like very excited about writing tests, some of them are not, but it's generally considered like a given that we will have tests for the repository. The question is like, are these tests going to help us catch bugs? And if they are, then why are we still having these bugs? The legacy code base, the tests were doing a lot. They would usually spin up the entire code base, so like more of an integration style test where we'd have to mock out data stores and whatnot. And so it became very difficult to add new data sources into a page or whatnot. So sometimes if someone was making a change that would add a new data source, that change would be tested in a way that wouldn't actually help catch bugs in the code they were writing. With the new code base, the benefits of having the stateless backend APIs is we were just able to hammer them with like kind of like a VCR test basically, where we, given this input, this output happens, and we can expect that, which allows us to be pretty sure that we're not making breaking changes to the backend APIs in the new code base. And then there's a lot of technologies around testing React components as small isolated components with the new, which we've taken advantage of for that as well, using like enzyme ingest and whatnot. The downside is it's harder to test as a cohesive thing. So if we wanted to have like UI tests with like making sure that we didn't have some sort of UI regression, that is something that when we were spinning up the old code base, fully was a little bit easier to do than with the new code base. So we have some like QA tests that actually like log in and click around, and those haven't gotten better, I would say. I'm not sure that they've gotten worse, but yeah, that's the one thing that's a little bit hard to test in the new world in our experience. Any other questions?
Then one final question.
At what point did the users see the difference in design? Was that at DOM stature or?
Yeah, that's a great question. So the design impacting the user changed a little bit with each approach. The DOM stature approach would have given them it would have made the header and the sidebar feel snappier if it was using, because like if the legacy code base was doing more kind of like as the header and stuff moved around, a little bit more jerky. But the visual impact was not a ton there. Usually how the users would see design changes would be as we would port pages, either with DOM Snatcher or with D2, port pages into being kind of using our component library and using more modern technology. So I don't know the last screen I have to go to get this homepage here, but the homepage was always sort of the first page we were going to port over. Is like making this page feel fast was number one, and then also using kind of modern components, so like you could like hover over these things and get little pop-ups and whatnot. And so we sort of wrote a new homepage as a React component, and in the DOM Snatcher world we use that, and then we continue to use that. So the first change they saw was when we rolled out the new homepage component with whatever method we used for that, and then as we ported over more and more pages into the React app, they started to see those benefits on a page-by-page basis. The one downside of, I should have mentioned this actually, the one downside of the D2 approach that the other two don't have is we have to keep this UI Chrome in sync between the two apps, because the old app is just doing it again a direct proxy through. So if we change like the header color or something in the new app, we have to redo it in the old app too, otherwise half the pages will have the old color. Luckily, this has not changed that much, and we were able to put in kind of like tests basically that say like, if you change this, fire alarms to make sure you change it in both places. But that is a downside that would have been avoided if we were able to use like DOM Snatcher After Dark or DOM Snatcher, because we were able to then only have that code in one place. So yeah, I think is that it? Perfect, thank you.